Solving inequalities. Addition and subtraction properties still hold, similar to adding and subtracting expressions and equations. Multiplication and division also still holds, with the exception of multiplying and or dividing by a negative number, which then causes the inequality to flip direction. So once again, addition and subtraction properties still hold, multiplication and division properties also still hold, just like solving for an equation or solving for a variable in an equation. The only exception is when you multiply or divide by a negative number. Alright, let's try some examples. In this case, our first example, -5 is less than -5. You gotta remember, do double check and make sure it's true. Is -5 less than -5? No, -5 is not less than -5, it's equal to -5. But in this case, we have an equality sign that it says that it's less than. So in this case, it's going to be a false statement. And that's our answer. It's a false statement. -5 is not less than -5. So now let's try the other one, the one that follows. The one that follows, notice our inequality. It says -4x minus 7 is greater than 1. And the question is, does -3, -2, or 0 satisfy the inequality? So it's just like saying in an equation format, does -3, -2, or 0 satisfy the equation? It'll be the same statement format. So let's try it out. Once again, keep in mind, inequalities, for an instance, you can think about them like having an equal sign rather than a greater than, less than, or greater than or equal to, or less than or equal to sign. So the first case scenario implies that we're trying -3 in place of the x. So there it is. We're substituting the -3 for the x. So -3 times -4, or -4 times -3. 4 times 3 is 12. Negative is positive. So we get 12. 12 minus 7, is 12 minus 7 greater than 1? Well, let's simplify first. 12 minus 7 gives us 5. Now we can check. Is 5 greater than 1? Is this a true statement or a false statement? Do remember to state it. So true, it's a true statement. So therefore, -3 is a solution then. Okay, let's try the next case, -2. So same equation as above, -4 times, in this case, -2 is the value that we picked for x. So substituting for x. 4 times 2, 8, negative times a negative, positive, so it'll be positive 8. 8 minus 7 is greater than 1. Well, let's finish simplifying it before we state that, right? 8 minus 7 gives us 1. Is 1 greater than 1? 1's not greater than 1, agreed. 1's equal to 1. So in this case, it becomes a false statement. So therefore, -2 is not a solution. Because when we plug in -2, it only gives us that 1 is greater than 1, which is a false statement. 1 cannot be equal to 1, right? So let's try the next case scenario, when x is 0. So -4 times 0, 0. That leaves us with just -7, agreed? So -7 is greater than 1 is our statement. Is -7 greater than 1? Let's see, what do you prefer to have? A -$7 bank account or a $1 bank account? Which one's bigger? The 1 is bigger, agreed? But this statement says that -7 is bigger. So definitely this is a false statement. So once again, 0 is not a solution. So if we continue picking bigger values, such as +1, 2, 3, 4, 5, etc., we're going to get, or continue to get, false statements or options that don't work. But if we continue choosing negative values, at least more negative than -3, meaning -4, -5, -6, etc., ideally this should work. Keep in mind, you're welcome to graph this, to visualize this on the number line. Okay, let's proceed with the next one then. So we have 8 minus x is greater than or equal to 2 minus 3x. For this one, we're solving the inequality. We're solving for x. So let's copy it over. So there it is. We copy it over to our paper. 8 minus x is greater than or equal to 2 minus 3x. Is this a true statement? Well, it's kind of hard to tell since we have variables. Okay, so keep in mind, the inequality sign is like having an equal sign. So temporarily, you're welcome to write an equal sign if it helps you visualize this. So that way you would say 8 minus x is equal to 2 minus 3x. And then you'd solve for x. In the equation format, you're trying to solve for x, meaning get rid of the x from one side of the equal sign. Which side do you prefer to have the x? On the left side or on the right side? It's your choice, right? But do remember, you want to make it positive is 1 in 10 to say. If you make it positive, it'll be easier for you in the long run. So let's try to see if we can make this a positive statement. In other words, positive for the x. Where would this become a positive? Well, I have a negative 3x on the right side. That's bigger than the negative x by quantity size, but not by sign, right? So therefore, if I want to have it a positive, it'll make it a bigger positive by getting rid of the 3 as a positive. So let's add 3 to both sides. And this will make it a positive x value. So we have 8 minus x plus 3x. We can combine those two together, right? That's going to give us 8 plus 2x, right? And on the other side, the 3x plus 3x, well, negative 3x plus 3x cancels out, agreed? So let's combine the x's. So once again, it gave us 8 plus 2x is greater than 2. And now we want to solve for x, just like before, right? So let's get rid of, what's easier to get rid of? Addition and subtraction, right? So let's get rid of the 8 to solve for x. Getting rid of the 8, minus 8 from both sides. Negative 8 plus 8, or 8 minus 8 will cancel out on the left side. That leaves us with just 2x. On the right side, 2 minus 8 gives us negative 6. So 2x is greater than or equal to negative 6 is what we have so far. Or if you have an equal sign for now, 2x is equal to negative 6, just for reference. Do remember you got to put your inequality sign at the end. So now let's get rid of the 2 via division, since it's multiplying with the x. Opposite of multiplication, since there's nothing in between the 2 and the x, it would imply multiplication. So opposite of multiplication, division. So dividing by 2 to both sides, notice the 2's cancel out on the left side. And that gives us that x is greater than or equal to negative 6 divided by 2. 6 divided by 2 gives us negative 3. Hey, did we ever multiply or divide by a negative number from one side of the equal sign to the other? We didn't, right? All we've been doing is simplifying on the same side negative signs. For instance, 6 divided by 2 gave us a negative 3, but we didn't technically multiply by a negative number or divide by a negative number. So that means our inequality signs are in the correct direction. So x is greater than or equal to negative 3. Okay, let's try it out again. Let's repeat this exact same example. But let's try to make it a negative x value. So let's copy everything down. Do remember, you can convert your inequality signs temporarily to an equal sign if it helps you. But otherwise, let's rewrite it. 8 minus x is greater than or equal to 2 minus 3x. Once again, we're repeating the exact same problem as before, except we're going to make it a negative x value at the first step. So it means we're getting rid of the negative x in this case, rather than getting rid of the negative 3x like before. So getting rid of the negative x, opposite would be plus x to both sides. So 8 is left on the left side, and on the right side of the inequality sign, we have negative 3x plus x, that gives us negative 2x. So we have 2 minus 2x. Well, let's cancel out on the top. And now we have left just the 8 is greater than or equal to 2 minus the 2x. We got to get rid of the 2, agreed? Subtracted from? Meaning the positive 2. Since it's a positive 2, the opposite is to subtract it, right? So what we do to one side, we do to the other. 2 minus 2 cancels out. 8 minus 2 gives us 6. So 6 is greater than or equal to negative 2x. Now take a look at this step here. We'll come back to it in a minute though. But we're dividing by negative 2 now to get rid of the 2, or the negative 2 I should say. Negative 2 divided by negative 2 cancels out. 6 divided by negative 2 gives us negative 3. Hey, look at that. But if we compare it to the previous example, our previous example gave us an answer of x is greater than or equal to negative 3. On the other hand, this example gave us that negative 3 is greater than or equal to x. And we should have gotten the same expression. But we didn't. Remember, if you multiply or divide by a negative number, notice that we divided by negative 2. Alright, so note that we divided by -2 in this case here. So that implies that our sign has to switch to the opposite direction. So instead of being -3 is greater than or equal to x, it's going to be -3 is less than or equal to x. So once again, notice our sign. -3 is less than or equal to x. And now this makes this statement be exactly the same as the other one, except in reverse direction. So, therefore this is a correct statement. There's our solution. Let's do a quick check. Notice you can pick any value, right? On the top examples, we have basically the same equation, right, on both sides of our check. So let's write it in here and substitute it with a 1. Wherever we had an x, we are replacing it with a 1. So 8 minus 1 will give us 7. And then simplify also the right side. -3 times 1 is 3. 2 minus 3 will give us -1, right? So there it is. Is 7 greater than or equal to -1? Let's see, is 7 bigger than 1? Yeah, 7 is bigger than 1, agreed? So it's a true statement. It works, from what we can tell up above, agreed? So ideally we should get a working statement if we did this correctly for our answers as well. So let's try it for our answers. Is 1, notice we're picking the same value as above, right? Otherwise, we wouldn't be able to say it works. So it has to be the same values you picked above. If it was false, then it has to be false here as well. But in this case, since it was true, our check should be a true statement also. Is 1 greater than or equal to -3? Is 1 bigger than -3? Yeah, I prefer to have a $1 bank account over a -3 bank account. Agreed? So it's a true statement. Let's try the expression that we got on the right side. So it says -3 is less than or equal to, and we replaced the x with a 1. Okay, is -3 less than or equal to 1? Yeah, it's less than 1. So it's definitely a true statement. So this implies, since both statements above and below are true, that both expressions, the way we solve them, are correct. So we just checked our answer. Let's try the next example. In this case, notice that it has fractions. I know you just love fractions, but we'll try to avoid the fractions. So let's bring it down. 4k plus 6 divided by 7 is greater than 3k plus 4 divided by 5. Since I know you love fractions, well, I'm just kidding. We'll try to avoid the fractions by getting rid of them. Let's see, since dividing and they're dividing everything on each of the sides, we can get rid of them by doing the opposite, meaning multiplying. So here, 7 divided by 7 would cancel out. But remember, what we do to one side, gotta do it to the other side, agreed? So times 7 on the other side. 7 divided by 7 cancels each other out. That leaves us with 4k plus 6. And on the other side, well, let's just bring down the values that we got now. So 3k plus 4 in parentheses times 7 divided by 5. Notice the 7 got added on the previous step by multiplication. Now, the 5 is the only one that's left that could make it look a little more complex. That's because it's a fraction, right? But otherwise we can get rid of it. Since it's dividing, opposite, multiplication. What we do to one side, we gotta do to the other, right? Now notice, on the right side, 5 divided by 5, because 5 is multiplying and 5 is dividing, right? Cancels out. And now that gives us that 5 times in parentheses, 4k plus 6, is greater than 3k plus 4 in parentheses times 7. Okay, so let's try it off over here to the top. Now we have enough space. So we gotta distribute in this case. Distributing 5 times 4k, 5 times 4k. 5 times 6, 5 times 6, right? Okay, let's try to keep it simple. 7 times 3k, 7 times 3k. 7 times 4, 7 times 4. And now we can simplify this. So 5 times 4, 20k. Okay, so 5 times 4 gives us 20, and let's bring on the k, right? 5 times 6, 30, and it's positive, so plus 30. On the other side of our inequality sign. So we have 7 times 3, 21, 21k then. 7 times 4, 28. All right. And now we got to solve for k. So where do we want the k's? On the left side or on the right side? It's your choice, right? Flip a coin if you must. Do keep that one in mind. Or draw out of a hat to see which side you prefer, left or right side. Recommendation though, always try to make it be a positive exponent. Which side does it make it a positive? If I move it to the left, I'm getting rid of the 21. 20 minus 21, whoop, that'll be bigger. So I'm going to get a negative number instead. I don't want a negative number. So let's move it to the right side then. So let's get rid of the 20k. Minus 20k to both sides. 20k minus 20k cancels out. And now, on the left side, we're left with just the 30. Okay, so that means on the right side, we have 21 minus 20k. That's just k, agreed. It leaves us 1k or k. Let's bring down the 28, so plus 28. And we're pretty close to being finished. Now, last step to solve for k. Well, let's get rid of the 28. It's a plus 28, so we're going to subtract 28. 30 minus 28 gives us 2. 28 minus 28 cancels out. So that tells us that 2 is greater than k. Let's go back and revisit real quick our complete expression. Did we ever multiply or divide by a negative sign? No. I don't think we ever multiply or divide by a negative number, right? So we have not multiplied or divided by a negative number. That implies that we did this correctly. We don't have to flip the sign in this case. The sign stays in the same direction. So 2 is greater than k would be correct. So there is our final answer for this particular question.